Welcome back to another session of Class 10 Mathematics, Chapter 1, Real Numbers. In this session, we'll be discussing the remaining questions of exercise 1.2. So, let us move on to the questions. Question number 3 of exercise 1.2. Find the LCM and HCF of the following integers by applying the prime factorization method. So, let's start prime factorizing 12, 15 and 21. We'll take 12. 2 is a factor, so we'll write 2, it is 6 times, again 2 is a factor, 3 times, 3 is a factor, 1, we'll stop. So we'll write 12 equals 2 times 2 times 3. Next we'll write 15. So we know 3 is a factor, 5 times, 5 is a factor, 1 time. So 15 can be written as 3 times 5. Next is 21. In 21, 3 is a factor, 7 times, 7 is a prime number, 1 time. So 21 equals 3 times 7. Now we'll find HCF. To get the HCF, we need highest common factor. The common factor, we know the common factor is 3. So there is 3 here, there is 3 here, there is 3 here. So 3 is a common factor. So HCF is equal to 3. Now to find the LCM, we'll take the common factor only one time. So 3 is a common factor. We'll take the 3 common factor one time and we'll write all other factors. So we have 2 here, 2 here, 5 here, 7 here. So 2 times 5 times 7. So the answer is 420. So the HCF is 3 and the LCM is 420. Now next question, 17, 23, 29. So you can see that 17, 23, 29, we already listed the prime numbers. So 17 is a prime number and 23 is a prime number and 29 is a prime number. That means they don't have any other factors other than 1. So the only common factor is HCF is 1. There is no other common factor because 17 is a prime number, 23 is a prime number, 29 is a prime number. There is no factors for these numbers other than 1. So the only common factor is 1. Now to find the LCM, so since there is no common factors, 17, 23, 29 are the factors of itself. So we'll multiply 17 times 23 times 29. The answer is 11,339. So this is the LCM. So HCF is 1, LCM is 11,339. Now the third question, 8, 9, 25. We can factorize 8. 8, 2 is a factor. So 4 times, again 2 is a factor. 2 times, again 2 is a factor, 1 time. So 8 can be written as 2 times 2 times 2. Next one is 9. So 3 is a factor, 3 times. 3 3s are 9. So again 3, 1 time. So 9 can be written as 3 times 3. Now 25. 25, 5 is a factor. Again 5. 5 is a factor, 1. So 25 can be written as 5 times 5. Now you can see here to find HCF, we need to find the common factors. There is no common factor means, so you can see there is 1 everywhere. 1 is a factor of every number. If there is no other common factors, other prime numbers as common factor, the HCF of these 3 numbers is 1. The HCF is 1. Now to find LCM, after removing the common factor, we need to multiply all the factors. So we need to multiply 2 times, 2 times, 2 times, 3 times, 3 times, 5 times 5, all the numbers. So that is 2 times 2 times 2 is 8. So 8 times 9 times 25 means it equals 1800 is the LCM. The fourth question is, given that HCF of 306 and 657 equals 9, find the LCM of 306 and 657. So we know the relation HCF times LCM equals product of the numbers. Product of numbers. So we'll use this relation to find the LCM. So HCF is NaN times LCM equals 306 times 657. So these are the two numbers. 306 and 657 are the two numbers. So if we are multiplying HCF, that is NaN, times the LCM, you must get 306 times 657. So the only unknown value is LCM here. So LCM equals, so we'll divide both sides by NaN. So we'll get LCM equals 306 times 657 divided by NaN. So after calculate, you can divide first before multiplying, because if you are multiplying, you will get a big number. NaN will be a factor of 306. NaN must be a factor of 657 because it is the highest common factor of both the numbers. So you can divide 306 by NaN first, or 657 by NaN. Then you can multiply the number. So the answer will be 22,338. So this is the LCM of these two numbers. Now the fifth question. Check whether 6 raised to n can end with the digit 0 for any natural number n. Now to number end with the digit 0, that means it must be a multiple of 10. A number which end with 0 is a multiple of 9. Example, you can see 10 is a multiple of 10 or 20. 20 end with 0, it is a multiple of 10. If you are taking 340, so it end with 0 means it is a multiple of 10. It is 34 times 10 is 340. If you say 1200, this is 120 times 10, that is 1200. So any number which end with digit 0 is a multiple of 10. That means 10 is a factor of that number. If 10 is a factor of that number, 10 can be written as 2 times 5. That means 2 and 5 must be a factor of that number. So we'll check whether 2 and 5 is a factor of 6 raised to n. Now 6 to the power n can be written as 6 can be written as 3 times 2, right? So in class 9 you have studied laws of exponents. So 6 raised to n can be written as 3 times 2 raised to n. And using the laws of exponent, this is 3 raised to n times 2 raised to n. And 3 is a prime number and 2 is a prime number. So it has this number 6 raised to n has only 3 and 2 as prime factors, because we studied the fundamental theorem of arithmetic. Any composite number can be expressed as a product of prime in a unique way. So once we get some prime numbers, it is unique. So you won't get any other prime numbers. Since there is no 5 as a factor, you cannot AND this number with 0. So to AND a number with the digit 0, there must be 1 5, at least 1 5 and at least 1 2 as a factor. So if you are getting 1 5 and 1 2 as a factor, the number will end with 0, otherwise it won't end with 0. In this, there is no 5, there are 2's, but there is no 5 as a factor. It will not end with 0. Okay. Now, sixth question. Explain why 7 times 11 times 13 plus 13 and 7 times 6 times 5 times 4 times 3 times 2 times 1 plus 5 are composite number. So first we will take the first question, this one. Okay. So it is 7 times 11 times 13 plus 13. We know that the plus or minus sign of an expression divides it into two terms. So in this case, there is one plus sign. So there is two terms in this expression. So 7 times 11 times 13 is one term and another term is 13. From both the terms, you can see that 13 is a common factor. So you can take 13 common. 13 common. So 13 outside the bracket. So what is remaining? 7 times 11 times 13 is taken from here is 1 plus 1 here. Now we'll get this is equal to 13 times bracket 7 times 11 plus 1. So we know 7 times 11 is 77. 77 plus 1 is 78. So it is 13 times 78. So 13 times 78 is a product of two number. Product of any two number is a composite number, because a prime number is a number which has only two factors, 1 and itself. It cannot be written as the product of any two numbers other than 1 and itself. So 7 times 11 times 13 plus 13 can be written as 13 times 78, the product of two numbers. So it is a composite product of, so it is a product of two numbers. It is composite. The same way we can do the next question also. So it is 7 times 6 times 5 times 4 times 3 times 2 times 1 plus 5. So since there is a plus 5 here, it has two terms. It has two terms. Now you can see 5 is a common factor. There is a 5 here, there is a 5 here. 5 is a common factor. So we can write taking 5 as a common. So this will be 6 times 7 times 6 times 4 times 3 times 2 times 1 plus 1. So we'll get it is 5 bracket. So we'll multiply 7 times 6 times 4 times 3 times 2. So it gives 1008 plus 1. That means it is 5 times 1009. So product of two numbers. Once we get a number as a product of two numbers other than 1 and itself, it is a composite number. It is a composite number. Composite. Why? Product of two numbers other than 1 and itself. Okay. The last question of this exercise, seventh question. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? In question it is given that Sonia takes 18 minutes for the one round, right? If you're starting with here, so they will take 18 minutes. For the second it will be 36 minutes, then it will be 54 minutes. That means multiples of 18. And Ravi will take 12 minutes, then 24 minutes, then 36 minutes. That means multiples of 12. So we can see they will take the multiples of 18 for the completion and multiples of 12 for the completion. Means we need to find the common multiple of 18 and 12, and it must be the least of the 18 and 12, that is LCM of 18 and 12. We'll factorize 18 and 12. 2 is a factor of 18, so we'll get 9 here. So 3 is a factor, 3 3 1, and we'll factorize 12. 2 is a factor, so 6, again 2 is a factor, 3, then 3 1. So we can write 18 as 2 times 3 times 3 times 1, and 12 as 2 times 2 times 3 times 1. Now we'll find the common. One of the 2 is a common and one of the 3 is a common. To find the LCM, we'll write the common numbers only once. So 2, we'll write 1 2 and 1 3 once, and the remaining numbers. So what are the remaining numbers? There is a 3 here, there is a 2 here. So the remaining factors we'll write here. So it is 2 and 3. Now we'll get the LCM. So it is 2 times 3, 2 times 3, it is 6 times 6 is 36. So 36 minutes. After 36 minutes they will meet. After 36 minutes they will meet. Okay, the exercise is completed. In the next session, we'll discuss the irrational numbers and how to prove the root 2, root 3 such numbers are irrational numbers. Thank you.